Okay, today we're taking a look at day 3 of our note packet, which is on page 9 here. We're talking about scatter plots. Okay, so a scatter plot is just an informative way that you can create a graph of data using two variables. Okay, so yesterday we were taking a look at one variable statistics, and we are just talking about one specific thing. Here we're talking about two different variables at the same time. All right. Remember, just like on a graph, we denote the variables with x and y, just like on the axes, and each point on the data is represented as an xy point. Okay, so x-axis is called something, the y-axis is called something, but each point is kind of labeled with that xy coordinate. So we're going to mainly focus on this chart for today and use it to create and interpret some scatter plots. So here are some cities across the country here, and we have their elevation listed in the first column. We have the number of clear days in the second column, the number of partly cloudy days, and the number of cloudy days. Okay, and this is an example of a scatter plot of that data. So you can see that the y-axis here is the number of clear days, and the x-axis is the elevation above sea level. Now remember, we talked about independent and dependent variables. This would be our independent variable, and this would be our dependent variable. Okay, that's why it's on those axes here. All right, so we have our y-axis and our x-axis. We don't have to label that normally, as long as we've labeled it with the words of what this represents. And you can notice that like the elevation in the chart, you can see like the lowest is 4 and the highest is about 5,000, something. So they've cut the interval from 0 and they've adjusted the um, scale to count by thousands. And then on the y value, which is the clear number of days, okay, we can see clear days is right here, that the lowest is somewhere around 40 and the highest is about 167. So, we'd want to be able to count that number. And so they've cut this into a scale of 25. Okay. And so what they've done is they've graphed all the points. So this first point is the point, right? You can take a look at it. One of the points is 4, and then 101, 1598. So that's what these points, 19, 101. You can kind of see that these are all, there's a few points right here, and you can kind of see where these all fall. Now, one thing we kind of want to do eventually get into is called a linear regression. We want to say, can we use this data to help predict what other cities might be if they have an elevation of, let's say, like 1,500, right? Somewhere in here. Where should that data fall? And we're going to get into that in the next few lessons. Today, we're just taking a look and seeing, is there some sort of pattern or trend here? If there is, then we can start to talk about predicting. So let's just focus on, can you tell if there's a trend here? Okay, so the big thing with scatterplots is if you are going to create a scatterplot, and we'll do this together tomorrow, okay, we want to make sure we label our axes, okay, that we are creating a scale for each variable, all right, and then we are graphing the points and then identifying, okay, any pattern here. All right, and this pattern, if you notice a pattern, is going to be called a correlation. A correlation just means as one variable changes, it tends to change, the other variable also tends to change in some manner, whether it's going up or going down. Okay, so let's take a look at page 10 here. And I've cut the graph from page 9 onto page 10. And so the first question is, do you see a pattern in the scatter plot? When you look at the dots, does it tend to form like some sort of pattern? And I would tend to say yes, there is some sort of a pattern, okay? You can kind of see that they're sort of bunched together, right? And they're sort of increasing as they go from left to right. That's sort of like the pattern that's being formed, okay? So the points okay? And it says, are they scattered? Are kind of scattered. Now, if they weren't scattered, okay, and you had a graph, you would notice that they form like a perfectly straight line. And so the less scattered would be like if the points are a little bit spread out, but they're sort of forming a straight line. Okay, so like those red ones. And then if it's super scattered, you might notice that there's points just all over the place, and they're really it's hard to tell like what's going on here. Okay, that would be like a really scattered graph. So they're kind of scattered, but generally, but we want blue here. Come on, people. All right, but they kind of tend to form a line. All right, so that's kind of the first thing here. Second, how would you describe the relationship between the elevation and the mean number of clear days in these 14 cities? So what we would say is, and you can kind of read the part, does the mean number of days tend to increase as the elevation increases or decrease? So you can see as the elevation increases, as we get further along to the right of the x-axis, the number of clear days also tends to go up. Notice that the pattern seems to be as I increase this number of days, the elevation, the number of clear days increases. So that's what we're going to write down. As the number, sorry, not the number of, as the elevation increases, the number of clear days, and we say tends to also increase. Okay? And so this is called a positive correlation, meaning as one variable goes up, the other one also tends to also increase. Okay. So do you think that a straight line would be a good way to represent this data, right? And you think about it, if I could just take a straight line and place it somewhere in the middle, does it look like it models that data pretty well? And I would say, yeah, yes, it sort of does. Those points sort of tend to form a line when you graph them. Okay, so yes. The points kind of form a line, but we could say, but are spread out. And this spread, we talked about spread out, they're not super close together, but they're a little bit close, is actually what type of correlation, whether it's a strong correlation, forms a straight line, or kind of a weaker correlation. All right. So this would sort of be kind of a, I wouldn't necessarily say strong, but I might say it's kind of a weak correlation because the points are a little bit spread out. But it's not bad. Okay. All right. Number 4, we are going to construct a scatter plot this time, and it's sort of already done for us, okay? And this is on your paper. I just brought the chart down here. Normally on your paper, it should look like this, right? Where you have the scatter plot right here, okay? I just moved it over and brought the chart down so we can kind of see it a little bit easier for us. All right. And so we have the y-axis labeled with elevation, and we're going to do z as the mean number of cloudy days. So we're going to do the number of cloudy days. Okay, so now, once again, the x is the elevation, so that's this column, and cloudy days is going to be all the way at the end. So Albany is 275, which is about, I don't know, about quarter of the way through, and then 185, so somewhere up here. Okay. And then we have the next one. So we have 160, we have 5,300, which is about here. We're at 87. And so we're just going to kind of graph these for ourselves. So go ahead and go through, and our x-axis and then our y-axis, you're going to focus on these two columns right here. Well, that wasn't supposed to happen. But these two columns right here, we'll hide them so they're kind of easy to see. All right. And then go ahead and plot your points. I'm going to pause it here. So pause the video, plot your points, and then come back when you're all done. All right, we're going to get something that looks like this. And I added some height here since our number of cloudy days actually got all the way up to 265. So I kind of added a little bit of room here, but you can kind of get the idea. This is what our scatter plot's going to look like. And you can see once again, right? Is there a relationship, and how would we describe it? So once again, as the elevation goes up, as we increase our elevation, what's happening in general to our cloudy days? And we can see that we're starting kind of high and we're ending low. So we can see that the number of cloudy days tends to generally kind of decrease as we get lower. Not always. You can see here the elevation's low. Here it's a little bit higher and it kind of goes up here. But overall, these points are to the left where the numbers are smaller, are higher than the ones on the end here. Okay? So we would say, is the relationship? We would say yes. And then as the elevation increases, kind of what we said before, the number of cloudy days, and we say tends because it doesn't mean it has to, so tends to decrease. C-R-E-A-S-E. There we go. Okay, so that would be our general statement there. All right. And then going down to exercise 4 through 7. So below there's 3 scatter plots. Each one represents 8 observations, and we kind of want to match them to what the questions are below. So which one of these scatter plots that we're looking at do we think is a relationship between height and weight? So think about it for a second. If you have a taller person, would you think that the weight would be bigger as you get taller, or should the weight get smaller as you get taller? So generally, if someone grows, what happens to their weight, right? And generally, I would say that as the height increases, so should the weight. Not always. So we would say that this would be represented by scatter plot 1. So scatter plot 1. And then y, we would say as a person's height increases, their weight, or that word we used before, tends to increase. All right. What do we think it might be height and SAT scores? So if you are a taller person, does that generally mean that you are smarter than somebody else, right? That you should get a higher score because you're taller? And the answer there would be no. So probably scatterplot 3, where everything's just kind of spread out and there really isn't a pattern going on here. So we would say scatterplot 3. Okay? And we could just say there is no relationship between height, or actually what we kind of want to say is, scrap that. Instead of saying no relationship, okay, we're going to say as the height increases, the SAT math score does not tend to increase or decrease. And we can say that this means that there is no relationship. There's no correlation there, okay? Just fixing up some of the letters here for us so we can kind of see them a little better, okay? All right, if one of the scatter plots is a relationship between weight of car and fuel efficiency, which do we think it is? So if the car gets heavier, do you think that the gas mileage should get bigger or smaller? And you would kind of say the heavier the car, the less miles gas it's going to get. So it should be scatter plot 2. Okay. And we would say as the weight of the car increases, the fuel efficiency tends to decrease. Okay, and we can see that on the scatter plot too here, that as we go up in the x-axis as we get bigger, right, our y values are getting smaller, versus the height and the weight, where our height increases and our weight increases. And then we have our SAT score and height. So as you increase the height, it doesn't tend to increase or decrease. It's just there's really no relationship there. Okay? Which one of these scatter plots does not appear to represent a linear relationship? And we would say scatter plot 3. Okay? We would say since there is, we'd say really, since the dots, since the points do not tend to increase or decrease. D-E-C-R-E-A-S-E, decrease. Okay? All right. So exercise 8 to 13 here, same kind of concept, except we're going to notice that not all points are going to form a line. Okay? So if you look at what's going on with scatterplot 1, we have the age of a person on the x-axis and the number of cell phone calls on the y. So you would say, right, as someone gets older, does the number of phone calls they make tend to increase or decrease? And we can see from the pattern that it sort of tends to decrease. And that it actually, you can look at the points, they sort of tend to follow a linear, right, progression, meaning that they sort of decrease at a certain rate, in a constant rate. So does it look like the points are scattered? We can still say yes, okay? The points like do not form a perfect straight line. Or they're not close to forming a perfect straight line, really, right? You gotta fix that. A-I-G-H-T. All right. But is there a relationship between them? And we would say yes, right? As the age increases, the number of phone calls tends to decrease. Okay. Is there a relationship between the number of phone calls and age? Does this appear to be linear? And we would say no, right? These aren't decreasing at a linear rate. It's actually taking that kind of asymptotal shape we talked about before, where this is kind of tending to increase or decrease and forming our right exponential, which we're going to do a little bit later, kind of regression here. So do the points look scattered? We would say kind of no, right? The points tend to form an exponential curve. Okay. And does it look linear? No, the points, right, do not form a straight line. Okay? So easy enough. All right. Scatter plot number 3 on the next page shows the prices of bikes. and the quality rating of helmets based on a scale that estimates how it's quality. What do you think? Is there a general trend here, right? If we look at the numbers at the start and the numbers at the end, does it sort of tend to increase or decrease? Do we think that there's any sort of relationship there? And are the points scattered? Okay. And do we think that this represents a linear relationship? So it's kind of hard to see, and I could argue both ways, but I would say that in general, the points down here are lower than the ones that are up here. So I would say there is a slight relationship. And the reason we would say it's slight, or we would say a weak relationship, is because the points don't form a straight line, right? I can sort of draw a line that models the data, kind of somewhere in the middle here. You could say it's right about there. Sort of models this, but the points are so spread out that they don't actually form that line. Okay? So we'll say yes, there is somewhat of an increase in the quality as the price increases. And we could say that the points are very scattered, but we could say they tend to increase. So this would be called a weak positive correlation. Okay, the points are not close to the line, but they still kind of form that an increase overall. Okay, and does it appear to be linear? We would say like yes, there is a slight relationship, positive. You could say positive. And it appears to be linear. Okay. So in general, a scatter plot can be used to investigate whether or not there is a relationship between two numerical variables. And we can also determine if it's going to be linear or nonlinear. And for this year, a nonlinear is essentially going to mean that we are going to be exponential. And we'll talk about how to actually do that a little bit later on. So for homework tonight, what I'd like you to do is use our chart that we've been doing, create a graph, okay, of a scatter plot between the elevation and the mean number of cloudy days per year, okay? Partly cloudy, partly cloudy. So once again, we're going to use this first column here, all right, and the second, we'll call third column here, okay? So you're going to do a correlation with those, and then use the second scatter plot 4 here to help answer these questions right here, okay? And there's no graph on 5. So don't worry about number 5 here. We'll say skip 5 and skip these ones because there's no graph, at least on mine. All right. Okay. So just finish up to 3 and then the graph right here for homework tonight. All right, guys. We will see you tomorrow, hopefully. Have a great rest of your day.